Hey class, so some of you have been asking about question number 3 on the homework, so I thought I'd make you a quick video. So what we have going on here, as the picture and description tell us, is we have this crate that is being pushed with a horizontal force to move it up a ramp. Not the most efficient way of moving it up the ramp, but that's the situation. And so we're told one important thing is that it's being pushed up at a constant speed. So constant speed means it's in equilibrium. So the sum of the forces, the sum is not a vector, the force is the vector, sorry about that. The sum of the forces is equal to mass times acceleration, but since acceleration is 0 at a constant speed, this is just 0. So what that means is sum of the forces in the x is equal to 0, and sum of the forces in the y will be equal to 0. So let's see what forces we have acting on our box. So first of all, we're given force F, the blue force here. We also know, since we're on Earth, that it's going to have a weight going down. So I'll call that mg, mass times gravity for the weight. And then perpendicular to the surface of contact, there's going to be a normal force as well. So that's the normal force. And we know from the fact that the ramp is at an angle theta, the normal force is going to be rotated the same angle away from the y-axis. So this angle here would also be theta. So based on my axes, what we can observe is that a component of the normal force will be in the x direction. F normal x is just going to be the normal force. Again, x would be the opposite side there, so multiplied by the sine of our angle theta. And then we have a normal force in the y direction, which is the normal force multiplied by the cosine of that same angle theta. So we can use that when we do some of our forces. So some of the forces then become relatively easy. We come over to do some of the forces, and we can start with the x direction. So we have the force F in the x direction. In the negative x direction, we have the normal force multiplied by the sine of the angle. And that's it. That equals 0. And then in the y direction, we have the normal force times the cosine of the angle theta minus, and then we have the weight. So minus mg equals 0. And we're asked to find F and the normal force. So straight away it's pretty easy to find the normal force, because if we solve our sum of the forces in the y direction equation here, we have normal force is going to be equal to mg divided by the cosine of theta. Plug and chug, you get the normal force, boom. So you can solve, we'll even write out like normal force equals some number. Boom, box worthy. Yes, feels good. And then easily enough, we can also solve for the force applied, because it's just going to be equal to our normal force multiplied by the sine of the angle. Once again, boom, box worthy. Yes. Alright, so hopefully that helps. Again, key here is realizing that it's at a constant speed, so the net force is 0, drawing a good free body diagram, and setting up some of your forces. Some people too, you can also alter your axes parallel and perpendicular to the ramp. The challenge there is then both your weight mg and your force F need to be broken into components. So I chose this way, so I only had to do one force into its components. Alright, well, hope you guys have a great weekend.